Hi, welcome to math learning number 2 of the unit statistics and probability. Our question for this video is, how do you choose or decide which probability is appropriate to use? Okay, so the math words that you need to make sure that you understand at the end are the following: theoretical probability, experimental probability, sample space, which we already talked about the last time, and it means possible outcome, and expected value. So get ready with your notebook to write down some notes. Okay, so what is theoretical probability? This theoretical probability is the probability that we talked about in the previous video. Okay, so this is the number of favorable outcomes, or the number of what you want to get over total number of possible outcomes. But this time I will be more particular with the math notation. So if we are going to get the probability, we write it as the capital letter P or the big letter P, and then whatever is the event, describe the event inside. Okay, so for example, a coin is tossed, so we write P, and then if we want to know the probability of getting a head, we just write head to be descriptive, and then you have here half because there's one head, and then divided by or over the number of possible outcomes, which is a head and or a tail. Okay, and it has the same probability with tail. So let's have another example of theoretical probability. So let's say we have a spinner, and these are all equally divided into 6 portions, so that we know that the number of our possible outcomes will be 6. Okay, so what is the probability? Take a look at the math notation I'm using. We want to get the probability of landing in 1. So there's only like one portion here that has 1 in it. So that means that is 1 out of 6. So 1 out of the 6 possible outcomes. Here's another one, a probability of the spinner landing in red. There are 2 reds here, so that we will have the favorable outcomes, or what we want to get. We have 2 that will be in the numerator, and then there are in total 6 possible outcomes. And we can still simplify this fraction or probability into 1/3. Okay, so if we want to use decimal, we can write 0.33 or 3300th, and it's approximately about 33%, a little bit over 33.3%. Okay, and then probability of landing in purple or an odd number. So here in the spinner we have one portion of purple, which is 2 also. So we have 1, and then odd numbers will be 1, 3, and 5. There are 3 odd numbers. So 3 plus 1, the purple, so that in our numerator we will have 4 out of 6. So 6 again is the total number of possible outcomes. We can still simplify this to 2/3. If we want to express our probability into decimal, that will be about 0.66666 or 66.666% or 66.67%. Okay, so this is just a review because we already learned theoretical probability in the previous video. So let's move on to experimental probability. So what is an experimental probability? Here we have, it is found by performing an experiment and observing or recording the outcomes, and then whatever is the result is our probability. So it is the number of times the event occurs, and then divided by the total number of trials, and or the total number of how many times you did it. Okay, so for example, you toss a coin 10 times, and then during the tossing, the head came out 7 times and tails 3 times. So the experimental probability of getting head is 7 out of 10, and then the probability of getting a tail is 3 out of 10. So the probability here is the result of actually performing the tossing of the coin. The theoretical probability is our expected value. That is what we are expecting to happen, that they have an equal chance of happening. So experimental probability is often used to estimate theoretical probability. Maybe you can check your value, or you use it to make predictions. Okay, especially if there's no theoretical probability yet, so then you use experimental probability. Okay, so let's have some few examples of the experimental probability. You can have in your notebook, you do it on your own. You can pause the video and then I will tell you the answer. Okay, so in this case, we have a pin and then you drop it, and then it may land on the pointed side, or point up or point down. Okay, so it was performed 20 times because we have here pointing up. It landed pointing up at 15 times, and then pointing the point down 5 times. So in total there are 20. So what is the probability that it will land point up? Okay, answer the question, and then here is the correct one. It's B, because it's 15 out of 20, and I simplify the fraction, so it's 3/4. Okay. Second example. Now we have tossing of the coin, and they did it 60 times. Then the head landed 27 times and tails 33. So what is the probability that it will land head up? Okay, answer the question, and then here's the answer. So 27 out of 60, we added 27 and 33, and that will be the total number of trials. So you have 60 as the denominator. Okay, another example is that they surveyed the color of the cars that passed by the school. Okay, and then here's the result in a table form. Okay, so add all of this to get your total number of trials, and that will be 30. Okay, and then answer what is the probability that it will be the silver will be the next car passing by. Okay, so what's the answer? It's half, or 50%, because silver is 50, and then the total number of cars that passed by in their record is 30 cars. Okay. And then our last example. So Molly asked number of people about their age and then recorded it and then organized the table in this manner. So we want the probability of the next person that Molly will ask based upon the result of her the experiment that she already did. What is the probability that the next one will be a person that is age over 50? So take a look at the table, find the age over 50 and get the probability. Let's have it. Okay, the answer is 41 out of 80. So the total number of people that Molly asked is 80 people, and then the people that have the ages more than 40 will be starting from 41 to 60 plus. So we added 18 and 23. 18 plus 23 is 41. 41 out of 80. Okay, so now let's compare experimental probability to theoretical probability. So there's this 5-sided spinner, and that they're going to use to play a board game. Marie is playing with Sarah. So the girls thought that the spinner was not fair, so they did an experiment because it seemed like some numbers came out more frequently than others, and then it's very noticeable because if you can see, the spinner is divided into 5, and they look like they have same portion. The area of where the numbers are written looks equal. They look equal. So they threw the spinner, or they turned the spinner 200 times and recorded the results. Okay, so for number 1, here are the results. Number 1 is 19, so 1 it stopped at 119, so the least number. And then 5 got the best result. 69 times it landed in 5. Okay, so seems like 5 is the most popular here when they should have the same chance of coming out. Okay, so let's work out the experimental based upon the results. The probability of landing in 1 is, oh, by the way, the total trials is 200. So 1 happened 19 times, so 19 out of 200. For 2 is 27 out of 200. For 3 it's 32 out of 200. And the probability on landing on 4 is 53, 4 out of 53. And then there you go. 53 out of 200. 4 out of 25 is if we simplify 32 out of 200. Okay, and then probability of landing in 5 is 69 out of 200. Okay, so for letter B, how many times do you expect each number to occur? Our expectation is that because you have 5 portions here and they seem to be equal, that each number will get an even chance of happening, and it should have been 1 out of 5. So we are expecting that it will land on each number. 1/5 of 200. 200 divided by 5 is 40. So 40 times. It seems like the closest will be which one? Okay, so you decide, is it 32, or it seems like 3 is the closest to 40, closest to your expected value. Okay, so now if you decide, what do you think? Is the spinner fair or not fair? Okay, when you are expecting it to happen 40 times. So this is what you are going to do. It's important that you learn when it is best to use the result in experimental probability or the theoretical probability. So the next thing that you're going to do is find the choice board for math learning number 2 and decide which one are you going to use to show the evidence of learning. Okay, so that's it, and I'll see you in the next video. Bye.